All right, so let's try another example. So I have here a, where am I again? Good, we're in differential equation land. So I definitely have a differential equation. What is my clue that this is a differential equation?
There's a y prime.
There's a y prime. Thank you. It's not the y, it's the y prime. Okay, so I got a differential equation. It's first order because there's one derivative.
Non-homogeneous.
Linear.
It's linear and non-homogeneous. My abbreviations are getting shorter and shorter.
Still wrote out first order though.
Yeah, I just want to get order and degree differentiated for a while longer. And then, yeah, I'll drop the order too. So, how do I try to solve a first order linear non-homogeneous differential equation?
Assume it's homogeneous and stuff.
Okay. Solve the homogeneous one first. So the homogeneous version would be y prime plus cotangent of xy is 0. I was hoping that this would serve vaguely as a trig refresher. I suspect that we could use that.
Yeah.
Is that accurate?
No.
No. No. Desperately no, Chris. Is that because you don't want a trigger refresher, Chris, or because you don't need one?
I do trig way too often.
Okay. All right, so to solve this, what do I need?
Trig identities.
Yeah.
Well, you could do the form that we know, right?
Okay, yeah, I could just employ the form,
Yeah.
right? Like, let me bust out the form. So the form says that when I have a first order linear homogeneous equation, the answer is given by y of x is a e to the negative integral of o cotangent of x dx.
That one's cosecant squared x, right?
No, that's the log as well.
Oh.
I have no idea.
Google's one.
No. It's easy. Okay, this is why I wanted to talk about this one. Cotangent seems like it would be hard to integrate, right?
You could use that.
Except cotangent is like cosine over sine or sine over cosine or one of those.
It's going to end up to be
It's
like...
cosine over sine. Right?
It's going to wind up like natural log of sine or something.
Yeah.
Yeah. So I'm just doing this over to the side, right? Like just off in the margin. I want to integrate cotangent. So that's the integral of cosine of x over sine of x dx, right? So how do you do this kind of thing? U sub. So you let u be sine of x. Why did I let u be sine of x and not cosine of x?
You got a derivative of x. Well, then it works.
Yeah, you want the derivative part to be on the top, right? So you can get at it. So your du is cosine of x dx. Did I screw up the minus sign on that? No. Good. So there's your, what was cosine of x dx?
du.
That's the du, right? Okay, so I got a du. What else have I got there?
Integral of 1 over u.
There's an integral of 1 over u du. Okay, so I'm going to get the log of the thing, right? You guys looking on that? Okay. So I think I got my constant, I think I got my e, and then I got log of sine of x.
Can you just say that's like 1 over sine of x?
Great idea. Right, you can't actually slash the e in the log right now because there's this minus sign in the way. So what do you do to get the minus sign out of the way?
Put it in the basement.
I'll Oh, you can put that in the argument of the natural log.
Yeah, there's a log rule that says you can take a number from out front of a logarithm and put it in on the argument as a power. Also, I should be a little bit careful here. What have I glossed here? Yeah, I glossed the absolute values, right? So really I should have the absolute value of sine of x in here. Right? Okay, so I'm going to rewrite that as a to the natural log of the absolute value of sine of x all to the minus 1 power. And then you can simplify a little bit more. So you can say that's a, what do you get?
Sine of x to the negative 1. Natural log. Or no, absolute value.
Absolute value of sine x to the negative 1. Okay, and then what? So, Anthony, what was your suggestion? Yeah, that's almost cosecant, right? When's that cosecant? Yeah, when it's positive, it's cosecant, right?
And we just put it on the box of a then, right? Like a over that?
Yeah, we just do, oh, you could do a over sine. Yeah, or a times cosecant. You guys see that? But only when sine's positive, right? Well, I don't know, there's like some weirdness, right? Like, really I should go back to this guy and be worried about when is P discontinuous, right? So when is cotangent not a continuous function?
Isn't it odd?
But cotangent's
multiple
cotangent's discontinuous anytime sine is 0, right? So that means that the only times this is going to work are when sine's either positive or negative, right? Because it can't cross 0 without discontinuing my coefficient in my equation, right? So I'm just going to assume it's positive for now. The negative would also be a thing you should consider, right? But it's either one or the other, so you can drop the absolute value bars and really include your plus or minus into the A. You guys with me on that? You should have some thought about this, though, right?
Should we write that on the side on our test?
Yeah, that would be great. If you want to just, like, thought bubble, I worried about blah, blah, blah. Before I dropped it, I thought about this and that and the other thing. Right? Yeah, a little paragraph over there would be awesome. Just to let me know you're thinking about it. At least, at the very least, a little thought bubble that says, I should have worried, would be awesome. Okay, so I got, I think, A cosecant. Cool. All right, now what?
Isn't this your y sub h?
Good. I really have been solving the homogeneous version all along. Right? Like, since here, this has all been about the homogeneous version. So really, I should have had little YH's in here. And which is your best particular guess? Like, now that you found YH, it's A cosecant. What should you do?
We can make A1.
Yeah, probably assume that the constant is as convenient as possible. Okay, so now what am I going to do? So like here I'm assuming YH is cosecant x.
Put in your guess.
Yeah, now I need my guess. So my guess is going to be y of x, right, is
Some kind of y or
General
x,
function.
yeah, some kind of u function, right, like u of x times
y sub h.
y sub h with the convenient constant,
Yeah.
right, which is cosecant. Okay, cool. Now, yeah, now you need to do the product rule, right? So you're going to get y prime is u prime cosecant x. Oops. Then what?
U, or plus U?
Plus u of x, right, or u. We don't suppress the of x's here. And then don't overthink this part.
Times, how about the derivative of cosecant x, because it's gonna drop out.
Is that
in
cotangent?
the end.
Clutch.
Right?
Oh, maybe.
Okay, yeah.
You can make your life a little easier because you know what's about to happen. Right? If you want to confirm that you did a good job solving the homogeneous equation, go ahead, differentiate that thing. Right? But if you don't feel the need to confirm that you did a good job solving the homogeneous equation because you're pretty sure you did, you don't really need to differentiate that thing because it's going to drop. Right? If you can't remember how variation of parameters goes all the time, though, you want to differentiate that to make sure it drops. Right? But when I do this plug-in, right, I'm going to get u prime cosecant x plus u times the derivative with respect to x of cosecant x plus cotangent of y, cotangent of x times y. And then what?
Equals x cosecant.
Yeah, equals your non-homogeneous part. So x cosecant x.
We gotta plug in the y.
Oh, yeah, and I have to plug in what y is, right? What was y?
U cosecant x.
U is, or y was u cosecant x. And then I had equals x cosecant x. Okay, now why was plugging y in important here?
To cancel.
Yeah, one because Davis, right? And the other one because all of this stuff is
Homogeneous.
that's the homogeneous equation all over again, so we can drop all that. So I got u prime cosecant x equals x cosecant x. So now what? Seems like u prime is x.
And we're not allowing, even if it was 0, we're not allowing it to be 0 because that had a problem with the cotangent domain, right?
Yeah, anytime sine was 0, the cotangent wasn't defined anyway.
Yeah. We
You
already
guys see
did
that? And so the way I would simplify this is I'm multiplying both sides by sine, right? You guys see that? So if you multiply through by 0, that would be a problem, right?
Yeah.
But you're not multiplying through by 0 because you're already restricted away from those anyway because of your cotangent function. And that's usually how this goes. Like usually at the end here, you end up with something you were already restricted away from anyway because this thing's related to your first problem. You guys see that?
So, is that the same U that was like sin x like way back or like?
Oh yeah, so this was just u substitution that I did in the margin.
Okay.
This is a different new u.
So then, what does this U prime equal x mean to this problem?
Okay, that means that u is 1/2 x squared, right? Plus a constant. Now, where did I get that u from in the first place? I put that thing in there, and I put it in there right here. You guys see that? So, I put it in there when I made this specific guess. That specific guess seems to have resolved itself into the idea that u needs to be 1/2 x squared plus a constant. And so my answer to this problem is
X squared cosecant x plus c.
1/2 x squared plus constant all times cosecant x. Guys with me on that? This would have been a little bit clearer maybe if I had over here, if I had done W substitution like Merrill likes to teach you guys to do. I don't know why I should use this W.
Oh,
Yeah.
well, it wouldn't be too bad.
It's what?
More spit.
Yes, he's gone.
More spit?
W, U. It's faster to say U than use
Yeah.
than the word W.
Yeah, I don't know why.
Twice as much.
Make it easy.
Okay. Questions, things? When does this solution work?
Oh, when is that? Oh, not multiples of pi. Everything but multiples of pi. And do it.
Seems like zero's multiple of pi. Yeah, seems like this thing works on the real numbers except z pi, where z is in the integers. Which is not obviously an interval, right? In fact, it's not an interval. It's what? Yeah, a whole mess of intervals, right? One for every integer.
Okay.
You guys cool with that? You could write that down in interval notation if you wanted. But why? You guys cool with this? And a plus or minus thing that I was worried about, right? What happened with that? Yeah, that's in that constant A. You guys cool with this?
Yeah.
Questions, things?
Questions?
No? Good?
I have class
So
in
would
like 2
that be
minutes.
an interval that we could use? Because you said if it was like super broken up and it like worked here and there in an interval.
Yeah, so this thing, each of these intervals is pi wide, right?
Right. So I feel like that would be like one of those ones that's like, oh, here's an interval and it works here, 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 and here, and here, but not like.
No, so this works at every point in intervals that are pi wide.
Oh, okay.
So I'm not worried about that like accumulation of issues thing because the issues are isolated. They're pi away from one another.
Okay.
And it works on every single one of those intervals. And the constant might be different depending on which interval you're on.
There's predictability.
Cool. What's that?
Predictability behind where the
Yeah, it's just going to depend on what the initial value you have is, right? So if I gave you an initial value, that would be in one of these intervals, right? And so then you would just make it agree and get your constant and everything would be fine. And it would work on the interval around the point at which you were asked.
Are we having homework?